So first, some necessary information. If we're going to try to write the equation of a line by looking at the graph of the line, first thing I recommend that you do is find two nice points on the graph of the line. We're really ideally looking for what we would, points that go through in a sort of crosshairs on the grid. And then we can determine the slope of the line by counting rise and run. And alternatively, we can write two ordered pairs and use the slope formula. Then we say, well, is one of the nice points of the form 0b? And if it is, we can go directly to the slope-intercept form, y equals mx plus b. And if not, we go through the point-slope form and change the slope-intercept form. So for example, let's say we were asked to write the slope-intercept form of the equation of the line shown below. I'm looking for two nice points. Well, I'm going to go right away with this point right here, 0, negative 1. And then scanning along this point looks pretty good as well, 5, 2. So now I could just count the rise and run. So what I see here is that the line increases 3, rises 3, and runs 5. And so I could say that the slope, m, is positive 3 over positive 5, or 3/5. Now if you wrote two ordered pairs, and then use the slope formula, m equals 2 minus negative 1 over 5 minus 0, we would have 3 over 5, the same thing. Either way, the slope is 3/5. Now, since one of the nice points was 0, negative 1, we can go directly to the slope-intercept form and write that y equals 3/5 x minus 1. Same exercise, same idea. Let's write the slope-intercept form. Now again, I've got a nice point here at 0, 6. And I've got another good point at 7, 2. Using the concept of rise and run, I see that the line is actually falling. The line falls 4 and runs 7. So then the slope m is negative 4 over positive 7, or negative 4/7. I chose the ordered pair 0, 6. Notice that that's of the form 0b, and so I can write that y equals negative 4/7 x plus 6. Same basic idea. Let's find two nice ordered pairs. Well, I don't have a nice ordered pair 0 something in this case. It's somewhere between negative 5 and negative 6, but I'm not really sure where, so I can't use the y-intercept. But let's see, where do I have some good points? Here's a good point. Negative 6, negative 9. And another good point is at 2, negative 4. So let's focus on those points using rise and run. We have an increase of 5 over an increase of 8. So the slope m is 5/8. Now I don't have a 0b, so I'm going to go through the point slope form using the point negative 6, negative 9. So then writing the point slope form, just reminding you, y equals m by x minus x1 plus y1. Remember, this is my x1 and this is my y1. So then y equals 5/8 of x minus negative 6 plus negative 9. Cleaning this up a little bit, I have y equals 5/8 x, 5/8 of x plus 6 minus 9. All right, now I wanted the slope-intercept form, so I'll apply the distributive property. Plus, thinking of that 6 as a 6 over 1 and multiplying fractions, I have 30 over 8 minus 9. Well, let me do a little bit of work here. 9 is 9 over 1, and I need a common denominator to add or subtract fractions, so let me multiply by a factor of 8 there, and I have 72 over 8. Simplifying, I have y equals 5/8 x minus, right, because 30 minus 72, that would be a negative 42 over 8. And 42 over 8 can be reduced, so I would write that y is equal to 5/8 x, and reducing by a factor of 2, 21/4. Now let's kind of check our work here. I said that the b, the y-intercept, was somewhere between negative 5 and negative 6. 21 over 4, or negative 21 over 4, is negative 5 and 1/4. Somewhere between negative 5 and negative 6. So this is reasonable. All right, last one. Same basic exercise. Let's find the equation of the line in slope-intercept form. Finding two nice points. Got negative 1, 1. That's a good point. And I've got 1, negative 4 as a good point. So the slope falls 5, runs 2. So m is equal to negative 5 over positive 2, negative 5/2. I don't have a nice b value. I know it's somewhere between negative 1 and negative 2. I can't say anything else about it right now. So let me use the point negative 1, 1 and go to the point slope form. So y would equal negative 5/2 of x minus negative 1, so that's x plus 1, and then plus y1 on the outside, so that's another plus 1. Applying the distributive property, I have y equals negative 5/2 x minus 5/2, right, because negative 5/2 times positive 1 is negative 5/2, and then plus 1, well, thinking ahead, I'm going to turn that 1 into a 1 over 1, multiplying by a factor of 2, I have plus 2 over 2. Combining the like terms, I have y equals negative 5/2 x minus 3/2. And again, if we sort of think, well, negative 3/2 is negative 1 and 1/2, so it's somewhere between negative 1 and negative 2, which is reasonable based on the graph.